in okay, so we'll derive one more formula to figure out that how we can figure out the critical load or stress of a short column. This is one thing. Other thing, we need to figure out that how we'll know a column is short and column is long. And I already told you that by counting only, and we can start it again. So we derive the formula is called Johnson formula for short and intermediate column. So the Mr. Johnson is the name of a scientist, okay, academician. What he did, he take a series of column made of same material with different length. So if he use different length, then he test in the lab that how those column is taking the load. So you see, if you vary the length of column, what is varying? Radius of gyration, slenderness ratio, because L by rho is called slenderness ratio, L by K or L by rho, same thing. If your length varying, then what will happen? Your L by rho is changing, right? So he make a graph along vertical axis. He put P critical, sigma critical, not P critical. Actually sigma critical, because P critical by area. That means this is sigma critical. He put along vertical axis, and along horizontal axis, he put slenderness ratio, L by K. Now what he did, he tests the column in the lab and take the data when it is failing. So let's see how we can describe it. It says Johnson formula of short and intermediate column is derived based on experimental or testing data of critical stress. Slenderness ratio L by rho or L by K for a number of column. So he took for number of column making the graph. Then he see sum of the column is following this line. That means he got several points, right? You see, what is the L by ratio for this column? Right over here, this L by ratio, right? Then similarly, what is the L by ratio for this column? This one. How much load he's carrying, stress, this much. For this one, this is L by rho ratio, and this much load he is carrying. So similarly, he did for all of them. And when he did for all of them, then he found that some column, he got this kind of point for particular some column. Okay. Now, how much load a column can take? Critical stress, how much? Do you know the yield strength? If I load more than the yield stress, then what will happen? Anyone?
Plastic deformation.
Plastic deformation. The material will fail, right? So if you want that material will not fail, then the deformation of the material should not be, or stress on the material should not be more than the yield strength. So the maximum stress of the column, it can take only SY. What is the SY? S and sigma is the same thing. I take copy from the book. They use S from the strength, okay? But instead of S, you can use sigma. It's same thing, okay? And some book, use SY or sigma. Anyway, so he figure out this one. So maximum stress a column can take only amount of sigma y, this much. So he found that a lot of column is following point are coming like that, and sum of point is coming like, if I take the heart sign, coming like that. Then, and also coming like that, okay, right over here. So he, then he connect this line. This line he's connect, all the dot he connect, right over there, all the dot he's connect. And interestingly, he found interesting things. He found that this curve PQTR, it is just following Euler equation. So in this graph, you see what is P by P critical by A. This is actually value of Y, right? Along Y axis. So this equation I can say, and you see pi 1 by C pi square E. This term also constant, right? Also constant. So what is L by K square? X-axis along L by K. So this equation I can express like Y equal to some constant C divided by X square, right? Then he figured out that this all the point exactly maintaining this Euler equation. This Euler equation. Okay. Now, in the red color with the love sign, dotted line, that means you are getting line BT, right? This is I was putting with heart sign this line, and that means he found two lines. And obviously, the highest stress will be SY. There is no doubt of it. Because if you load it more than SY, material fail. Then plastic deformation means fail. We don't want any structure should have plastic deformation, because after deform, it will not come back in previous position. Now, he found this equation, but he was thinking that what is the pattern of this equation? This. And this equation, this line, interestingly, he found that they're touching at point T of PQTR graph. So he like to found this equation, and he found that this is the same way like parabolic equation. Now you see, if I like to look at this point, for this point, what is L by K ratio? Point B. Javed Hussain. Javed, roll 100. You are on your computer? Javed? No.
Yes.
You're on your computer? Okay. Tell me what will be the value of L by K at point B? What is the L by K at point B? Anyone?
Full stress.
No, L by K below. The graph is L by K, x-axis and y-axis is stress. So at point B, stress is SY, that means sigma y. But what will be the L by K? 0.
0.
Right? L by K is 0. Similarly, right, if I talk about this point, what is my stress? You make a line toward the left side. This mass will be stress, and getting bottom, this mass will be L by K. Okay. So you see, for point B, L by K 0 and stress will be SY. And then he found that when this line touches at point T, then he found that the stress coming about half of SY. that means half 0.5 sigma y, half of yield strength. And then what will be the L by K ratio? Then he just went down toward the bottom. He say L by K is this much. Okay. Now he is trying to figure out the equation of line BT. So you see, line BT has a 2 point B, and from point B, I can derive one condition. What is condition? That point B value of L by K equal to 0. And what is the stress? Critical stress, or P critical by area A, this equal to sigma y, or I can say this equal to SY. This is one thing, right? Other thing, that L by K at point T, L by K equal to how much? L by K equal to, they are calling it L by K1. So find L by K equal to L by K1, then your stress, that means P critical by A, this is coming 0.5 SY. This is coming 0.5 SY. Okay. So if we gauge the equation and use this two boundary condition, then we can figure out the equation of line BT. So that we'll try. Okay, so let's see, go through the next slide. And interestingly, you see from point T, if you go to our right, that means all the column is following Euler equation. And from point T, if you go to the left, then all the column following this line. Okay, line is BT. That means point L by K more than this value, more than L by K1, that will call it critical value, then column will be Euler column. You can use Euler column. If L by K value is less than this value, then you have to use the Johnson equation. This BT graph is called Johnson equation. For example, you figure out in your I'm giving you a column. You know what is the physical length of the column. You figure out cross section area of the column. Then you figure out the length of the column, I minimum, I maximum. Then you figure out rho equal to I minimum by root over I minimum by area, right? Then you found L by rho. For example, you found 100. Okay. Then you figure out L by rho 1. L by rho 1, you are getting 105. So your left side or right side of the graph. This is L by rho. This value is 105. And L by rho, you got 100. So your left side or right side of the graph.
Side.
Nozdul Islam, roll 29. Are you there? You are in the computer? Roll 16, SecAP. Are you in computer? Okay, roll 29, 16. They are not in the computer. Okay, so anyone give the answer? Anyone?
Left side.
Left side. Good. What is your
Sir,
ID?
left side.
Both of your ID?
Sir, 91.
91. Good. Other one?
18.
18. Okay, good. Very good. So you see left side. Then when you are left side, that means you cannot use the Euler equation. But we didn't derive yet the equation for BT curve, right? But we have to derive it. So let's see how we can derive. So Johnson, what he did, he take a equation, this equation. 1 second. P critical by A minus B by L square. That means X equal to Y. This is P critical by A by Y, because Y axis is P critical by A. So he found Y equal to A minus B X square. and AB is the constant. And this constant we can figure out. We have two boundary conditions, like at point B, sigma critical equal to P critical by A equal to SY, then L by K equal to 0. So you see, you put L by K equal to 0, and sigma critical by A, P critical by A equal to SY. So you get value of A. And your value of A is SY. So you got one constant. Now you need to figure out constant B. What is the constant B? That sigma critical equal to 0.5 SY right over here, and L by K equal to L by K1. So these two boundary conditions we use. So we found I think same line boundary condition. I put it over here. Okay, so if we use the second boundary condition, then we are able to know the value of B. And there is a one thing. What is the point T? You see, point T is the common point, right? It is on the Euler equation. That means TR curve, QTR curve, and it is also on the BT curve. And I know the coordinate of point T. What is the coordinate of point T? Coordinate of point T, that means sigma critical by area. This equal to X equal to, if I say in terms of XY, that will be L by K, in the bracket it is 1, L by K 1. This is your x-axis, right? Comma, what is the y? Y equal to 0.5 SY. So this point we can apply in the Euler equation. So if we apply in the Euler equation, we'll get something. There you see. So this condition will apply right over here. So how do you get it? What is your sigma critical? Equal to 0.5 SY. So we put 0.5 SY. Okay. And what is L by K? L by K equal to L by K1. Now, this L by K1, we will not call it no more L by K1. We will call it critical slenderness ratio, because if you are on the right side, that means your column following Euler equation. If you are on the left side, then your column is following equation BT. So when you this value is substitute in this equation, then we are equation this one. Instead of L by K1, we can say L by K critical. So 0.5 SY equal to pi square EC L by K critical whole square. Then L by K, figure out from the L by K. So L by K equal to root over this much. Just rearrange the equation. And if see over here, instead of SY, I just put sigma Y. And this L by K, if you look carefully, you see that it is pi 2 pi r square, 2 pi square. It is a constant. E is a constant. N condition is a constant. Sigma Y is a constant. So this L by K critical does not depend on the length of the column. It only depends on the N condition and the material property, right? So now coordinate of point T, what is coming now? Coordinate of point T is coming X. What is my X axis? L by, one second, let me take the text. So it will be L by K critical. L by K critical. This is my X coordinate, comma Y coordinate. So what is the Y coordinate? 0.5 SY. This is my condition for point T. And this condition will apply in this equation. right over here. We already got value of A. Value of A become SY, right? So you see, I should mention somewhere that we got value of A, right over here. We got value of A. So we already got value of A. Now we just need to figure out the constant value of B. How will figure out? Put this coordinate, point T, in this equation, because T is the common point. You can apply in the Euler equation, then you can apply in the Johnson equation. So you have put over here. So P critical by area, that equal to 0.5 SY. A equal to SY, then minus L by K1 whole square. But L by K1, we know this is the critical cylinder ratio. We already figured out that value, that L by K equal to L by K critical. So instead of L by 1, we put L by K critical whole square. Now, what is L by K critical, value of L by K? We already figured out in the previous slide. This is value of L by K critical. So this value, we put it over here. Then from here, by rearranging the equation, you figure out the value of B. So you see, we got value of A equal to SY, we got value of B. Is substitute over here, we'll get the equation. So right over here, you'll see after substitute these two value in this equation, you got this one. This little bit bigger equation, this one. Okay, this one is L by K. And if you rearrange it, then it becomes this equation. Okay. This is L by K. So this above equation is known as Johnson equation of short and intermediate column. It is only valid for the region of the left side of the graph, right? Because if your value become higher than this one, then you need to use Euler equation. That means you, without measuring, you know this is a long column. I will use the Euler equation. But your radius of gyration less than that value, then you know this is a short column. You need to use this equation. So what you have this equation? Sigma critical mean T critical by A, SY, that means sigma y 2 pi K. K is the radius of gyration, and cylinder L by K means cylinder ratio into 1 by E into C. C is the end condition. So if you will go in the next slide, I just summarize everything in the in this slide. If SY, that means sigma y, same thing. I put over here that L by K is greater than L by K1 or greater than L by K critical, then you use this equation. If L by K less than L by K1, then you use parabolic Johnson formula. Then you use this equation. Okay. And how will get the L by K value? This. So any question? Anyone has any question about the derivation? Hello? No question? Anyone?
So,
No question. So you understand, right? So you see,
Yes, sir.
the Johnson formula is actually derived from some experimental result, not the analytical. It will be analytical because after you draw the graph, then you decide what will be the equation of that graph. Then from the boundary condition, they decide it. And normally you see the graph will look like very nice, and actually not. If you
Sir,
do,
will the graph always be parabolic type?
always parabolic type, yeah, and it's proved by experimentally. But you see, I'm showing all the line in a like straight line. Seems like I got the very nice point, but actually not. You might have some point over here, over here, over here, over here. You just then, you know, optimize
Best fit curve. We have to select the best fit curve.
do the curve fitting, take the best point. But whatever assumption you are making, has to be valid by analytical solution. That's he did. He figured out the point T coordinate he put in the both equation and he proved it and justify that although he got some point right over here, but he said, no, we will not taking more than yield point, because if stresses become more than yield point, that means your column will be fail. Okay. And whenever you do some experiment in the lab, either fluid mechanics or solid mechanics or heat transfer, you might have same problem. You see your point is haphazard, not giving the straight line. Then what you'll do? You make the adjustment or you do the curve fitting. Okay. So let's summarize all the formula, then we can solve one problem. Okay, let's see. So this is the summary of all the formula. Right now we learn two formula, Euler equation and the Johnson formula. Euler equation for long column, Johnson equation for short column. How did you know when you use the Euler equation? If your L by K is higher than L by K critical. If L by K less than L by critical, then use Johnson formula. And here is the end condition of the column. And you need to remember all the end condition. The value will not be given in the exam. And in textbook, you see there is only 4 end condition. But in reality, when you go for something design, you see end condition might be 6, 7 end condition. Okay. But right now, remember that this 4 end condition, their value and the 2 formula. I put it over here. You see, I put over here the 8 cases. The end condition value is 8 value over here. And you see, this is pin-ended column. This is from the aircraft, the stress analysis book of the airframe structure. You see what happened. This one, it can rotate, but it cannot move upward or move side. Same thing this one. So that's why this is called pin support. Right over here, this is called pin support. Then you look this one. This one is a fixed column because it cannot rotate, because it's, you put an nut bolt in the both side. You try to rotate it, it will not rotate. Or if you look this one also a fixed column. Okay. So this slide you don't need to remember, just I'm showing you in reality how we figure out the column has a fixed support or it has a pin support. And in reality, you might see there is a more than 8. Okay. I work for a company, they use 10 boundary condition, end condition. Okay. You see this load is right over here and there is a shear load. Instead the load is over here. So there's a lot of variation. But undergrad level, you only know the 4 end condition. Anyway, and we will solve this problem. You say a 32-inch long I-shaped bar is made of this material. It's made of aluminum extrusion. Okay, and FCY is given. FCY 70 KSI, value of E given. So what is FCY? Anyone? You know? You don't know. What is FCY? FCY, what is the unit given? KSI. So obviously it is stress. So we use sigma Y, right? Sigma Y. Sigma Y mean stress. When you put sigma T, that means tensile yield strength. Normally we mean sigma Y. But if I use sigma CY, what does it mean? Compressive yield strength of the material. If I use sigma T, that means tensile yield strength. And some book, they use, instead of sigma, they can use S or they can use the F. That's why you see in my slide, sometimes I put all the 3 letter, because whenever you found instead of sigma, you found the FY or FUT. Some book or handbook, you see FUT. FUT means sigma UT. that means ultimate strength, tensile strength. If we found sigma UC, what does it mean? Ultimate compressive strength. So over here, SY is given, 70 KSI, E is given. Now, what they want? Find critical buckling load for pin-to-pin support. So pin-to-pin support, that means value of C is given. Solve part A. If length of the column is 28 inches instead of 32 inches. So right over here, we are saying length of the column is 32 inches. So instead of 32, if column length is 28, then what will happen? That we are seeing over here. Okay. And this one light over here, this is I-beam. You walk down through a neighborhood, you might see a lot of building are using this one. Also, a lot of bridge, they use the I-beam. So how will get the cross section? Cross section you see right over here, little bit round. They have the fillet. The dimension is not given. They are giving the distance from top to here. They are giving this distance, and they are giving this thickness, right? So obviously, this distance and this distance is same. They are not giving distance from here to here. That means this flange is in the middle, and you already see in the middle. And dimension is given: A equal to 3.5, B equal to 2.5, and C and D equal to 0.08. So at first you need to figure out physical length of the column, given 32 inches already. Then end condition. Both case end condition pin to pin, that means C equal to 1. Then you need to find area, cross-sectional area, you can figure out. Then moment of inertia, I minimum you need to figure out. Then you figure out rho or K. Then figure out L by K ratio. Then you figure out a column, it is a short or it is a long. Okay. So let's see how we can solve it. Let me stop this sharing. I think I have a solution over here. 1 second. Say, this one right over here. Are we able to see the slide? Hello?
Yes, sir. So we have only 5 minutes left, sir.
Yeah, we can solve it, or if you have emergency, you can leave. Okay, so the length of the column is 32 inches, end condition equal to 1. And you see FCY or SY equal to 70 KSY. That means kilo PSI. So you multiply by 1000. Value of E is given. You need to figure out P critical if length of column is 32 inches. You need to figure out P critical if length of column is 28 inches. So what you need to do, you need to figure out the moment of inertia. Moment of inertia and cross-sectional area. So cross-sectional area you can easily figure out. If you divide this in several segments, then you figure out the area. Rectangle, length into width, right? So area got this much. Now, if this is an CG of this structure, cross will be in the middle because this is symmetry. So what need to do? You need to figure out IYY, you need to figure out IXX. You figure out the both one, from there you need to take the minimum one. So how will figure out the IXX? You already know from your solid mechanics class. Okay. So I will use the simple way I can figure out. How? We are taking IXX and IYY. Okay. At first, I like to figure out IXX. So if I take this bigger portion, bigger block. So what is the B? For rectangular cross section, our inertia is 1/12 BH cube. So 1 by 12, and what is the B? Ix is B mean 2.5, and A is 3.5, right? So this one I am taking the whole cross section, but there is a some vacuum, right? That means what I'm saying, there is no material right over here, no material right over here, right? So we need to subtract this one. So 1 by 12, what is the B? B will be distance from here to here. You can easily figure out. Total distance 2.5. Then subtract 0.8, because in the, if you look in the question, this distance, this transition 0.8. So 2.5 minus 0.08 divided by 2. And then you will get this distance from here to here is 1.21. So 1 by 21 is the B. I like to figure out the inertia of this empty rectangular. There is no material. So I subtract this, I put minus sign. 1 by 12 B H cube. H is remain, how much will be H? H will be distance from here to here. And you can easily figure out. Okay. Then you got Ixx. Now you need to figure out Iyy. So how will you get the Iyy? 1 by 12. Similarly, Iyy, I take the bigger one. So 1 by 12 BH cube. Instead, B will be 3.5 and H will be 2.5. Then I have to subtract which one? I have to subtract this area right over this area. And remember, we are figure out the inertia respect to the CG, right? So we are figuring out respect to the CG, and you see right over here, we multiply by 2. Why? We multiply by 2 because there's two area, left side and right side. So we got the bigger area. Now you need to subtract this one. But you see 1 by 12 BH cube. So our B is 3.34. The distance from here to here. This is B. And what is the height? 1.21. Right? Now, this inertia you are getting respect to this point. But we need inertia respect to this point. Respect to, if I draw a love sign, respect to this point. But this portion, we love hard, is getting respect to this point. So how we can figure out the respect to this one? You need to add one thing, AD square. Because you see, we know if you apply parallel axis theorem, that ICG equal to Ixx plus A into D square. A mean area. So then we add the area. Area into D square. What is the D? Distance from this CG to this distance. Easily you can figure out. Half of this thickness 0.04 and half of 1.21. That I did over here. Half of 1.21, then half of 0.08. Then we have two area, on left side, on right side. Then we just multiply by 2 and subtract. So this is my Ixx, this is my Iyy. Then from these two, you take the minimum one. So I minimum equal to Ixx into Iyy. I make the automatic, you give me the result. But you can just figure out which one is the minimum. So I minimum equal to this one. Then you figure out radius of gyration. I minimum by area, you got this one, right? Now you figure out the slenderness ratio, L by K. So in that case, our L by K equal to this much. Okay. Now you need to figure out L by K critical by formula. So you got L by K equal to 54. And you are getting 57. So you are right side or left side now? Anyone? L by K 57 and L by K critical 54. That means you are in the right side. So that means you need to use Euler equation of column. So it's a cylindrical ratio L by K greater than L by K critical. So it is a long column. We need to use Euler equation of column. We almost finish. Just bear with me a few minutes, 2 minutes. So this is the
Sir,
Euler.
are we calculating the moment of inertia collectively?
Yeah. If the cross section is too complex, we will not give you. But this type of like a simple rectangular, right? Then you need to figure out by yourself. If I give you complex structure, then I will give you the inertia. So this is formula for P critical. We found this one. Okay. Now they are saying length instead of length 32, right now length is 28. How you can figure out? So length of the column is 28 inch. Now you figure out L by K. You see your L by K critical, it is not changing, it is remain same because it does not depend on the length, right? But your physical length of the column is reduced to 28. So now we figure out L by K and you got L by K equal to 50.1. That means right now you are on the left side. Okay. So you see you are getting now you need to use the Johnson formula. It's a cylindrical ratio L by K less than L by K critical. So it is a short column, need to use Johnson equation of column. So this is the formula. And all the value I already mentioned before, you put it, you get result this one. Okay, so a column is shorter, that means you are getting higher load. It able to carry more load. Sometimes you make a design a column and you design it, your drawing is released, and the installation engineer, they like to put in the aircraft. Sometimes we see that parts does not exactly same as mentioned in the drawing. If length might be given in the drawing is 20 inch, but you like to installation, you see pace is 18 inch, not 20 inch, then what need to do? Then the installation engineer, he will look to the report that who designed these parts, who's the design engineer, who is the stress analysis did. So he will call you that, hey, Mr. X, here is the problem. The length of the structure is not fit. There is space 2 inch short. How I can install it? So you need to immediately tell that you can cut the column by 2 inch because it is safe. Because it's 2 inch, then column will carry more load. Your structure or aircraft or ship will not be fail. Okay, but say you design a column with 34 inch, but they found the length 38 inch. So obviously you cannot install that one, right? Because length is shorter. Then what need to do? You need to redesign, you need to analyze this again. Because length is increased, then load carrying capacity will be reduced. Okay, so this is the giving an example that how in real work you can apply your knowledge of solid mechanics. Okay, or knowledge of column. Any question so far?